So we'll be solving inequalities. In this case, we'll start by dealing with absolute value inequalities. So we're going to make sure again that we write our answer in interval notation as well. So the first thing that we're going to do in these problems is to isolate our absolute value. So we're going to subtract 3 from both sides, and that's going to give us the absolute value of 1 minus x over 2 is greater than or equal to 2. So keep in mind, absolute value has two answers. So we're going to set up two separate inequalities. One as 1 minus x over 2 is greater than or equal to 2. Next, we're going to set it up as the opposite. So we can set it up 1 minus x over 2. Now, it doesn't become greater than or equal to, it changes because we're really multiplying through by a -1, which changes the direction of the inequality. So we're not only changing the sign of the 2, but we're also changing the inequality to face the opposite direction. Now we need to clear our fraction, so we're going to multiply by the LCD, which is 2. So when we do that, 2 times 1 is 2. The second one, the 2's reduced, and that leaves us -1x, and that's greater than or equal to 4. So we're going to subtract 2 from both sides, and that leaves us with -1x is greater than or equal to 2. Now our last step is to divide by a -1. Remember, when we divide by a negative or multiply through by a negative in inequalities, the direction of the inequality symbol changes. So we're dividing by a -1, so x would be less than or equal to -2. Now we solve the second inequality, so we clear the fraction by multiplying through by 2, which is the LCD. So we have 2 times 1, which is 2, minus the 2's reduced, that leaves us 1x, is less than or equal to -2 times 2 is -4. So we're going to subtract 2 from both sides. So we get -1x is less than or equal to -6. And again, since we're dividing by a negative, the sense or the direction of the inequality symbol changes. And a negative divided by a negative is a positive. So whenever I'm writing something in interval notation, what I do is like to put it on the number line first. So let's review one thing real quick. So whenever we're dealing with inequalities that are greater than or equal to, less than or equal to, our endpoints, we use brackets to indicate it includes that endpoint. When it's just greater than or less than, we use parentheses around that endpoint to indicate that that point isn't a part of the solution. So when I'm graphing these two on the number line first, I put my two endpoints on, -2 and +6. Now look at my inequality. The first one says the values of x are less than. Read from your variable. X is less than or equal to. Or equal to means I have a bracket. Less than means I'm going to the left. For my second inequality, my endpoint is 6. Those values that are greater than or equal to 6, equal to means at 6 would be a bracket. Those values that are greater than go to the right. Now I have two intervals, so I use a union sign in between, indicating my answers are either in the first interval or in the second. So to write my interval, I start with the point furthest left. Since my graph here continues indefinitely to the left, it continues forever in the negative direction, and we call that negative infinity. The point furthest right in my first interval is -2, and we include that point because the inequality was greater than, less than, or equal to. Now for my second interval, my point furthest left is 6, and my graph continues indefinitely to the right, or to infinity. Infinities always have parentheses. Now 6, since my inequality is greater than or equal to, would be included in my solution. Next, same thing. We start by isolating our absolute value. So I'm going to subtract 2 from both sides. And this leaves me with the absolute value of 1 minus x over 2 is greater than or equal to 3. Now I set up my two absolute values. I have 1 minus x over 2 is greater than or equal to 3. And then I do the opposite, keeping in mind since I'm multiplying through by a -1, I'm changing the direction of the inequality sign as well. So it's 1 minus x over 2 is less than or equal to -3. So I'm going to clear my fraction by multiplying through by the LCD, which is 2. So this becomes 2 minus 1x is greater than or equal to 6. Subtract 2 from both sides. So -1x is greater than or equal to 4. And then I'm going to divide by a negative, which is going to change the direction of my inequality symbol. So x is less than or equal to -4. For my second inequality, again, I want to clear the fraction by multiplying through by the LCD. So this gives me 2 minus 1x is less than or equal to -6. So I'm going to subtract 2 from both sides. So this gives me -1x is less than or equal to -8. So dividing by a negative again, I change the direction of my inequality symbol, and -8 divided by -1 is +8. So now I set up my number line. My two endpoints are -4 and 8. Why did I put the -4 to the left? Because it's smaller. Remember, this is a number line. So as I move to the left, my numbers get smaller. So again, -4 is included. So I use brackets, and the values less than are to the left. For 8, I also use a bracket, and the values that are greater than are to the right. So to write my interval, the point furthest left in the first interval is -infinity, and I use parentheses. My point furthest right is a -4, and since it's included, I use brackets. Since there's two intervals, I use union, meaning or. 8 is included as a part of my solution. That's the point furthest left in the second interval, and my graph continues indefinitely to the right or to infinity. My next example, I'm dealing with the absolute value is greater than or equal to 0. So I have the absolute value of x plus 3. It really doesn't matter what's inside the absolute value symbol at this point. What this is saying is when I get the answer, what values can I use so that my answer will be greater than or equal to 0? Remember, that's the definition of absolute value. So it doesn't make a difference what number I plug in, it will always yield a true answer because absolute value is always greater than or equal to 0. So the numbers are either 0 or positive. Since that's what this is stating here, what can I use? I can use all real numbers. So I can use anything on the number line and that will work. So I can use any number from negative infinity to positive infinity. So you don't have to do any work on that. And let's look at the next example. Same thing, but it says, when I take the absolute value, when will it be less than 0? And the answer is never, because absolute values, remember, are always 0 or positive. So when will the absolute value be less than 0? Never. So we use the null set. Okay, let's look at a compound inequality. So here we have negative 2x minus 4 is between negative 16 and negative 10 inclusive. Some people can read it as negative 16 is less than or equal to negative 2x minus 4 is less than or equal to negative 10. The way we solve this is the same way as we'd solve any equation or inequality, but we're doing it simultaneously. So what we're going to do is isolate our variable. So what I'm going to do is add 4. Now when I add 4, I add it to both sides of the inequality symbols. So this is going to give me negative 12 is less than or equal to negative 2x is less than or equal to negative 6. Your inequality symbols always point to the smallest number. So negative 12 is smaller than negative 6. So our last step is to divide by a negative 2 because we're solving for 1x. Keep in mind the rule. If I divide by a negative, it flips the inequality symbol. So now they're both going to change directions. Negative 12 divided by negative 2 is positive 6. And negative 6 divided by negative 2 is positive 3. Notice they're pointing to the smaller number. 3 is smaller than 6. But we solve it the exact same way, keeping in mind again, if we multiply or divide by a negative, we change the direction of our inequality symbols. If I want to write this in interval notation, I come to my number line, I put in my boundaries, which are 3 and 6. Remember, 3 is smaller than 6, so it'll come to the left. So look at where x resides. It's between 3 and 6. So in this case, we have brackets for both 3 and 6, and it includes all the numbers between 3 and 6. So we're going to have a single interval. So it's going to go from 3 to 6, including both 3 and 6, because of our inequality symbols being or equal to. Our next example, we have 20x plus 4 is greater than 4 times the quantity 4x plus 8. So on the left-hand side, there's nothing to do at this point. On the right-hand side, I'm going to distribute the 4 times the 4x and the 4 times the 8. So I'm going to subtract 16x from both sides because I want to isolate my variable. That means I'm going to subtract 4 from both sides as well. So 20x minus 16x is 4x. The 4's reduce. And 32 minus 4 is 28. I'm going to divide both sides by 4. So x is greater than 7. So again, let's look at a number line. We have 7 on the number line. That's our endpoint. This says where the values greater than, they're greater than to the right. But remember, since it's not greater than or equal to, there will be parenthesis around the 7. So in interval notation, this starts at 7, and the point furthest right is infinity. And both of these would be inside parentheses.